Hello everyone, welcome back into the another session on object-oriented programming. Dear students, since last couple of lectures, we have been discussing about features of object-oriented programming. We have convinced ourselves that moving forward in the programming field, object-oriented programming is the only option. And that's why we have chosen to learn object-oriented programming. In order to learn the concepts of object-oriented programming, we have decided to learn C++ language. So with the help of C++ language, we will be learning some of the features, some of the functionalities of object-oriented programming. So today, we will first begin our discussion by differentiating the C and C++. So, as you all know, C is a procedural language, whereas C++ is non-procedural, that object-oriented language. C is inherited from the BCPL or B language, and C is considered as a procedural language. Means entire logic in the C language is divided into small functions, and these small functions you have to combine to get your entire program. Whereas in the case of C++, it is object-oriented. Object-oriented in the sense, here you have to discuss, you have to think in terms of objects. So whenever you will have a problem in front of you, you will not think in terms of functionalities, but you will think in terms of the objects. Okay, how many objects are there? What actions that objects are supposed to perform? What information that object will need to store with itself? So the orientation of thinking has been changed in the C++. So that's why we call it as a object-oriented language. And then C is top-down approach language. Means in the C, while designing a program, we use top-down approach. Now what is a top-down approach basically? Top-down approach says that you will have a main module, that is the main program, and then onwards you will have the small functions which you will need to accomplish your task. So that is nothing but top-down approach. So you will start with the main problem, and then there is a control program. That control program will then call small procedures which are required. So in the C we have a main function. Always we start with the main function, and within the main function you write down the other functions which will be called later on. So that's why it is called the top-down approach. C++ is called as a bottom-up approach because here the approach is different. We start developing the small modules first, and then we construct the main module. So if you have a problem, we start designing the small features or small procedurals which will be required afterwards, and then we will have the main program which will call it up afterwards. So the way of designing is bottom up. We will start from the bottom and we will move upwards towards the main program. In the C, we start from the main program and then we go with the small procedures later on in the down phases. So that's why C is called as a top down, whereas C++ is called as a bottom up approach. Then C requires all the variables to be defined at the starting of a scope only. Now that was the downside of the C. As C came into existence before the C++, it was earlier decided that the scope of the variable should be defined at the beginning of the program only. But in the C++, we can declare the variable anywhere in the scope wherever we will need them. So wherever its first use will be there, we can declare these variables. So this is how in the C++ things have been simplified. In the C, all the way you have to go up, and then only you have to declare all the variables, and then you can use it afterwards. But in the C++, it's not mandatory to declare all of them at the top only, but in between also, wherever you will need, you can declare the variables. So that's the feature, that's the advantage of the C++. Then in the C, we use malloc and calloc functions for online memory allocation or on-demand memory allocation. In the C++, instead of that, we have a new and delete operators. Instead of functions, here we use new and delete operators to use memory allocation, or whether we wanted to allocate or deallocate memory at the runtime. Okay, so malloc and calloc was used in C for runtime memory allocation and deallocation, whereas in the C++ we use new and delete operators. These are some of the differences between the C and C++. When we will dive more details into the C++, you will understand how different C++ is from C in terms of its structures, in terms of its usage, and in terms of its flexibility. So let's move on. Let's get started with understanding the structure of C++ program. So as we did in the C, we have to include all header files at the beginning of the code only in the C++ also. So basically, what is the role of header file? So we all know that we have to use certain functions in our code, and there are many functions whose definition we cannot write it down because it is so lengthy and it is already available somewhere. So instead of writing down the definition, you have to refer to the file from where the definition can be extracted during the runtime. So that's why we have to give the header files at the beginning of our code. In the C, we used stdio.h and conio.h files. These are the header files that we used in the C language, isn't it? The reason we use these header files because we had to use printf and scanf functions. So in order to use printf and scanf, I cannot directly straight away go and use it because compiler doesn't know what to do with the printf, how to work with the printf. In order to tell how to work with the printf, how the logic is defined of the printf, for that I will need to refer to the header file stdio.h. So compiler will go into stdio.h file, will read the definition of printf, and accordingly it will work. So for that, header file declaration is essential. Now the basic concept behind having this kind of a structure is that to minimize the code length. To minimize the length of the code and to also minimize the size of the code. So here when we refer to particular file, only those files will be taken into consideration while the code will be compiled. In the C, I gave you an example. Let's consider you have a library where you have to go and you have to read particular definition. Let's say you wanted to understand some of the concepts of physics. Now as you wanted to understand the concept of physics, what generally you will do, you will go into the library, you will get the book which is written on the physics, and then you will go through the index, and from that you will understand that particular definition or that concept, isn't it? Consider that library is not arranged in that way. You don't have a books segregated according to physics, chemistry, maths, or according to subjects, but instead we have a giant book over there which includes everything. So what you will need to do in order to understand the concept, that giant book contains everything. It contains physics, it contains maths, it contains chemistry, English, everything. Now in order to understand the concept from the physics, you will need to take that big book and you will need to go across each and every page of that book to read out the definition to understand the concept. It's really difficult, isn't it? Instead of that, the way the library has been arranged now, it becomes a lot more easier for you to face the concept. Because once you know the concept is from particular subject, you can directly go there and get the book of that subject and can understand the concept. Similarly, in the C and the C++, we have done the structure of library. So we have a huge library, but that library is segregated, it is divided according to different functions, different work scenarios. So for example, I wanted to work with the graphics, there is a dedicated library for that. If I wanted to work with maths, there is a dedicated library for that. If I wanted to work with the file system, there is another dedicated library for that. So based upon the nature, based upon the way I will need to use the functions, I will refer to only those libraries, and those libraries will be taken during the linking phase of our code, and then from that the definition will be read and that definition will be included in our code. So that's why this header file declaration section makes our code more compact and more understandable. So that's why this header file declaration is essential, and this is how C programs have been structured. Followed to header file declaration, we have another section that is called as a global declaration section. Now we all know there are two ways in which we can declare the variable. There is a global scope and then there is a local scope. Global in the sense the variable or the contents over there which will be available across everywhere in the code. The limitation is only that entire program. Throughout the program, anywhere I can use that program definition or that variable name or that identifier. Whereas in the case of local variable, that is only limited only for that function. So only for that function it will be applicable. Outside of that function it will not be applicable. So whatever the variables that I wanted to use across different functions, I will declare them at the global level. So that's why this global declaration section is given. Okay, this is one of the way to communicate between different functions. So let's say suppose one function is calculating the total of the subjects and there is another function which calculates the grade according to percentage. Now how these two functions will communicate between themselves? So in order to facilitate their communication, I will need to use global variable. This is one of the way. Of course, there are other ways also available, but this is one of the way. So what I will do, I will set the variable which is global and to that I will set the percentage. And the same variable will be accessed by the another function which is setting up the grade, which will read the contents of the percentage variable and accordingly it will set the grade. So this is how global communication can happen. Let's say suppose this global variable concept wouldn't be there. What would have happened? In order to communicate from one function to another function, there is no other way. There is no other easy structure through which you can communicate. But just because we have something which is global, that's why we can easily use the variables across multiple functions. One of the simplest way to understand this is consider you have a classroom. And in the classroom, you have written second year computer department. Now, once it is written second year computer department, that definition or that title will be applicable only for your classroom. It will not be applicable outside of your classroom, isn't it? But let's say suppose I wanted to give a name for the college, where it should be written. It should be written within the classroom or it should be written at the outside of the college at the entrance. It should be declared at the outside of the entrance of the college because that is global. Because the name of the college is applicable for all, isn't it? Whether it is a classroom, whether it is a lab, whether it is anything else, it will be applicable across entire premises. So that's why it should be declared global. Take another concept like I wanted to give some notice. Now consider that notice is only for the computer department, second year computer department. So in that case what I will do, I will come to your classroom and I will paste the notice in your classroom. So that is only applicable for the second year computer department only, isn't it? But let's say suppose I wanted to have a notice for all the students learning in the college. So where it should be placed? It should be placed at the centralized notice board because it is global for all. So whatever the notice I will be displaying at the central notice board, that will be applicable for all the students. So that is global, isn't it? And the notice which is put in your classroom, that is local. So whatever you wanted to put as a global, you will put over here in the global declaration section. Followed to this section, you have a class declaration and method definition section. So as we know, in the object-oriented programming, we have to work with the objects. And in order to have the objects, we will need to create them first. And in order to create them, we need class. So here we have that mechanism, that is class declaration and method definition. So here you will create a class. Inside the class, you will have a methods and the data associated with that class. So this is nothing but a structure of a class. So this is nothing but a mechanism that you will create in order to produce the objects. So that class definition will go over here in the class declaration section. Then followed to that, we have a main function. Main function is nothing but a function from where execution of code will start. Now in the just before one slide, I said we have to use bottom-up approach over here. Now in the main function, you have to create the objects of the classes that you have declared over here. So that's why in certain way it is bottom up approach. Because we started the execution from the main. Always we start with the main function only. Whether it is C, whether it is C++ or whether it is Java, we always begin the execution from the main function. So once we started the execution from the main function, inside in the main function, we will create the object. So in order to create those objects, we needed class. So these class are available at the top of this main function. So how the move of the control is there? So it is bottom to top. So that's why it is called as a bottom up approach. We started with the bottom because we started with the main function, which is written at the bottom of the class declarations. So we start with that. Then we have to create the objects. So in order to create the objects, we will again move upward because we have to refer the class for that, because the class is nothing but a mechanism through which only we can create the object. So main function will then refer to the class, and then from the class we will get the objects, and once we will have those objects, then we can start using these objects. So in certain way, how the control has moved from bottom to top. So that's why it is bottom up approach. And then followed to that, we have a method definition section. So what are the methods that we wanted to declare outside of the class that we can declare over here? So once we will go in details of this particular structure, you will understand how this structure can be used in the C++. Let's understand this code which prints hello onto the screen. So we began with the declaration of header file. So we used #include iostream.h. Similar to stdio.h file in the C, where we have to use printf function, here in order to use cout, we used iostream.h file. So iostream stands for input output stream. So in the C++, we consider it as a stream. Stream in the sense, the sequence of bits. Like when we say there is a stream of water in the sense there is a sequence in which the waves are coming, isn't it? So similarly over here, we consider input and output as a stream of data. Stream of a data in the sense the bits will be sent in a streamed fashion, means one after the other, one bit, then another bit, then another bit. This is how the data will be sent or received. So in order to work with input or output, we have to use this file iostream.h file. So this is equivalent to stdio.h file in the C. Then we used int main. Now this is function. As we all know, our program will always begin its execution from main function. So hence we have written int main. Now main is the name of function which is by default should be there in order to run the program. Without the main function, program will not be executable. Int is nothing but a return type of this function. Means whether this function will return something to the caller or not, that will be decided by this return type. So here we used integer as a return type. That means this function is going to return some integer value to its caller. Now who is the caller? Now in this particular case, if we are using compiler, so compiler is the caller of the main function. So to that caller, main function is returning some value, and this value is returned to just acknowledge whether the code was executed or not. So this is just an acknowledgement that we are sending. But as far as we are executing this code within the compiler environment, this is like a simulated, this is within the sandbox. So this output, this return value is not at all usable in the case of when we are using it in the compiler. But in the real application, once your code has been compiled, it is converted into .exe file, and when you are running it in the actual environment where compiler is not there, the code has been already compiled. In those cases, this return type will actually say whether the program which was called by the operating system has been executed successfully or not. So this is an acknowledgement to the operating system, because once you will click on the any file from the operating system or from the file explorer, there is a system call which gets generated at the back. So that system call will then call this particular program's main function, and then whatever is written in the main function, that will start executing. Now, how come operating system will know whether the program was successfully executed or not? So for that, this return type is mentioned. So when we are returning 1, depending upon the 1 or 0, what operating system will get from here, it will understand whether the program was successfully executed or not. So that's why this return type is essential. Then we have a cout over here. So this particular statement is equivalent to printf. A printf was a function, but here cout, we are using it as an operator, and then we are using this hello word to print on the screen. So this statement we will try to understand in more clearer manner once we will get into details of the cout and cin, means printf and scanf statements, which are equivalent over here for as a cout and cin in the C++ code. Having said that, we have understood the C++ program structure, and then we have taken a small code in the C++ and we also understood that. Now in the upcoming session, I will first explain you what is cout, how to use that cout, and what these symbols actually depicts over here, that we will see. And we will see some other details of the program and programming in C++. Till then, keep studying. Thank you.